In this circuit here, we are told that there is a battery that is supplying 12 volts and the battery has eligible internal resistance. So it's applying the current to this circuit, whereby the current is going to flow that way. And then we have an ammeter here to measure the current, and we have a voltmeter that is connected across this 4 ohm resistor, which is parallel to the 2 ohm resistor. We have also a 5 ohm resistor which is in series with the rest, with these 2 resistors that we have here. So we are supposed to find the current, the ammeter reading and the voltmeter reading. The first thing that you need to do whenever you are given a question like this on current, you need to find the total resistance in the circuit, and you can see these 2 resistors are in parallel. And when you have 2 resistors in parallel, what you need to remember is that you need to use the formula 1 over this resistance 2 plus 1 over this second resistance, then we say raised to power -1. So the total resistance for these 2 resistors in parallel will be 1 over 2 plus 1 over 4 raised to power 1, then plus the resistor that is in series, which is going to be 5. So if we work it out, we can now put that in our calculator. 1 over 2 over 3, so that we don't start rounding off as early as possible. Ohm's law voltage, from Ohm's law, voltage is equals to IR. Then we can be able to say the current that is flowing through the entire circuit, which is I, is going to be I is equals to V over R, which means that our answer is going to be the V is the total voltage, which is 12, divided by R, which is 19 over 3. So if we take our voltage 12 divided by answer, we are going to get our answer approximately 1.89. So the current is going to be 1.89 amperes. So the value of I, which is the current in the circuit, is going to be 1.89. And since we ask current, we have to remember the units for current is amperes. So already we have that value. So the next question that we are going to focus on is whereby we are finding now stating the reading of the ammeter and the reading of the voltmeter. So you need to remember that the voltage drop for this section here plus the voltage drop across this second resistor is going to give us 12 volts. So I mean the voltage drop here plus the voltage drop for this section must add up to 12 volts. So if we can manage to work out the voltage drop for this section, we subtract it for this from 12, we are going to get what's the voltage that is going to be used by the 2 resistors, 2 ohm and the 4 ohm. So we are going to work out potential difference PD across 5 ohm resistor, so that we can be able to know what is the voltage drop across this section. And this is going to be V is equals to IR, and that is going to be current. Already we have gotten it, because this current will go here, it will split and then split this one, then again it will rejoin here. We shall have a current that is passing through this resistor is 1.89. So we are going to say 1.89 times the resistance that we have here, 5, and that's going to give us what? Times 5 translates to 9.45. So this value here is 9.45 volts. So if we were having a voltmeter here and it's connected across this point, it will have shown 9.45 volts. So the reason as to why we have worked out this value is so that we can be able to know what's the potential drop in this section, and that's going to be 12 minus the potential drop. I've already told you that the potential drop for this part plus the potential drop for the entire of this section will add up to 12. So it will be 12 minus 9.45, and that potential drop in this case is going to be 12 minus 9.45, which is going to be 2.55. So this is going to be 2.55 volts. So since this resistor is parallel to this one and this section will be having 2.55, so the voltmeter reading is going to be 2.55 volts. These two components are in parallel, so they are going to have the same voltage, which is 2.55. But when we are talking about this ammeter reading, of course, we really don't know which current really went here and which current went down here. We can be able to use the voltage in this second resistor. We can be able to use the voltage across this 2 ohm resistor and its resistance in order to work out the current that is passing there. So we are going to say the reading for the ammeter is of course the current reading. So we are going to say current is actually V over R. Now in that case, we have said that this resistor will experience 2.5 because it's parallel to this, also will experience 2.55. So that will be 2.55 divided by the resistance, which is 2 for that resistor there. We are going to have divide by 2, that's going to be translating to 1.275 1.275 amperes. So the reading for this one is basically 1.275 amperes. All right, so basically that's what you do when you're working out current and voltage for resistors, for electric circuits. And if you got value from this particular video, consider subscribing so that anytime I'm going to upload a tutorial like this, you'll be notified. See you in the next video.